double angle formulas. Formulas for the sine of 2x, cosine 2x, tangent and cotangent 2x. Let's take a look at our first problem. If the cosine of x is 1 over square root 10 and x belongs to quadrant 4, can we find the sine of 2x? Now you know you've memorized the formula here for the sine of 2x, and we have this. Sine 2x is equal to 2 sine x cosine x. So I know I can fill this in as 2 times, well, I don't have the sine of x, but I do have the cosine of x, 1 over square root 10. So it looks like I'm going to have to find the sine of x to put in here. Let's go up here and draw a little triangle for reference. A little right triangle in here. I'll label this as angle x. It has a cosine of 1 over square root 10. So if I label the adjacent side with 1 and the hypotenuse with square root 10, then by the Pythagorean theorem, I know that this side is going to be the square root of this squared minus this squared, which is going to be the square root of 10 minus 1, which is 9. Square root of 9 is 3. So that tells me that the numerical value for sine x is 3 over square root 10. And then since x terminates in quadrant 4, I'm going to have to put a negative sign right here. So I use this little diagram right here to just get my numerical value for the sine of x, and then I use the fact that it terminates in this quadrant to get this negative sign. Now I can multiply this out. You see it's very simple. 2 times 3 is 6. Square root 10 times square root 10 is 10. I've used the negative sign, so the rest of it's pretty easy. Let's go on and look at the next problem. Now I want to graph y equal 4 minus 8 sine squared x. Let's start by factoring a 4 out of each term. What's left is 1 minus 2 sine squared x. Then I recognize this as the expanded form of cosine 2x. So I can rewrite this as 4 times this expression right here can be rewritten as cosine of 2x. So it looks like I have a graph with an amplitude of 4 in a period of 2 pi divided by 2, which is just pi. No phase shift, it's not reflected, and it's a cosine curve. So let's see if I can sketch the graph of that real quickly. So I'll just draw a little coordinate system here. Here's x, here's y. And let's see, I want to have an amplitude of 4, so I'll simply label this as 4 on the y-axis and this as negative 4. I want a period of pi, so let's just go out to pi. Halfway will be pi over 2. Halfway there will be pi over 4, so this must be 3 pi over 4. And I sketch the graph of a cosine curve. Starts up here at the amplitude, goes down to 0, down to negative 4, back up to 0, and then back up to 4. So a nice cosine curve. It's going to look like this. It's kind of hard to draw this on these whiteboards, but it's okay. You get the idea. Nice one complete cycle there of that cosine curve, and I used my expansion formula for cosine 2x in the other direction. Here's the expanded form. I rewrote it as just cosine 2x. Identify amplitude and period. We have the graph. One more problem. Let's just verify that sine 60 is 2 sine 30 cosine 30, just so we can have one of these double angle formulas verified. So I'm going to look at this and say, okay, sine 60, see if I can get this right this time, square root 3 over 2. That's 2 times, okay, sine 30. Let me put a question mark here because I want to see if this is true. Sine 30 is 1/2. Cosine 30, square root 3 over 2. Let's see, the 2's divide out. I have square root 3 over 2 equal to square root 3 over 2. So that does check, and I have verified that those two expressions are equal to each other. Just so we can add some weight to these double angle formulas and show you that they actually do work out. Most important thing about the formulas in this section is that you have them memorized.